Evening, good day, wherever you are in the world, and welcome to Haystack Live. This is our last Haystack Live of the year of 2021, but we hope to run a packed program next year. And this presentation will be recorded to YouTube and will be live as soon as we can. I'm Charlie Hull from Open Source Connections. We're the search and relevance people. I'm sure you'll know who we are. Very pleased today to have Dmitry Kan and Daniel Wärnå. Apologies for pronouncing your last name, Daniel. I'm sure I'll get it wrong. Who are going to be talking about 5 ways to increase result diversity at web scale. Just before we get into that, just to mention, we have our Think Like a Relevance Engineer training for next year. We have dates in February for the Solar and Elasticsearch courses. I'll warn you, the Elasticsearch course is already half sold. And then we have Learning to Rank following in early March. Do check out our website for details of that. So I'm going to, without further ado, to hand over to Daniel and Dmitry. I will say we have our normal rules today, which is please keep your microphone muted. I may have to mute it for you if I can hear some background noise. If you've got questions for Dmitry or Daniel, you can put them into the Zoom chat. And after our talk, I'll be asking those questions on your behalf, just to make sure everyone gets a fair chance. I may open it up for wider discussion. We've got a small, but obviously highly engaged crowd today. So that should be fun, and you'll get a chance to ask the questions based on the talk. Daniel, I'm afraid I don't know you very well, but Dmitry is a mainstay of Relevant Slack, and also has been doing a fantastic podcast talking to lots of people at the cutting edge of search. And he promises he has more podcasts to come. And both of them are at silo.ai. So I'm going to hand over now to Dmitry and Daniel. There we go, chaps. Over to you.
Thank you very much, Charlie, for the kind introduction as well. And happy to be here, sharing some knowledge, some experience, hopefully to have some good discussion today as well. So we'll start with slides. I hope you guys can see the slides.
Yeah, it seems to work.
All right, cool. So let's get going. So today we'll have the bit of slides and also the demo, and hopefully that will be useful for some of you working in the diversity. Why search diversity and why at web scale? As part of like web scale development, we have been working on vertical search engines. So for example, like job search or real estate search. And we launched several search engines with our client in multiple regions. And the first problem that, beyond other quality issues, the first problem that struck us was that the results were not extremely diverse, and you only can show something like top 3 on the screen. That's like a mobile phone screen, so it's very limiting. Another connection to web scale here is that when you build an algorithm, it needs to pass through tough quality gates, especially around performance. So obviously you cannot choose a very precise, nice algorithm, but it's very slow. So you'll have to kind of ditch that and kind of move to maybe a simpler algorithm. But you still would like to kind of pursue the goal of diversity in some meaningful way. So hopefully we'll discuss today 5 ways you can do that, starting from something very simple to something a little bit more elaborate. Just one single slide about Silo AI, and I promise that the last one. So we are the largest private AI lab from the Nordics. We've been growing quite steadily, doubling each year. So currently we have more than 200 machine learning AI experts in different fields, you name it, NLP, computer vision, automatic speech recognition, demand prediction, and so on. And we also have multiple sites. So like in the Nordics, in Finland, in Sweden, in Denmark, also in the UK, in Switzerland, and the US. So I would like to introduce Daniel Wärnå. So he's actually the first AI engineer at Silo AI. He's also full stack. So he always surprised me with how quickly he can jump on like a UI problem or maybe backend. And also, curiously, he practices circus outside of works. So that's really cool.
And to present Dima, I guess Charlie already mentioned a few things, but he has worked on tons and tons of various search engines. He's the host of the Vector podcast, and also kind of works on or helps out with the Cupid project.
All right, with intros out of the way, Dano, I think you want to take this slide.
Yeah, so just to establish some very basic sense of what we're doing. So we can just define that a like search application is something that it gets some input from a user, whether it be text or voice, or I guess something else could classify as well. And then we just want to understand the query, find relevant things related to that, and then show them in some relevant order, whatever that order might be, where the key point being that precision is not maybe always the best or most useful metric in this case.
Yeah, so you're saying, Dano, that sometimes imprecise might be useful as well, right?
Right, at least we hope so.
Okay. So I thought I will kick off with some related work in the space. Obviously, it's not exhaustive, but some of the latest blog posts by Daniel Tankelang, he actually kind of replied to some of the requests on relevancy Slack. And so he actually asked me to say that this blog post sometimes is a little bit like controversial. So he says that it's not always a good idea to diversify search results, but obviously he means that you still can do it. You just need to be smart about it. And so he says here that sometimes maybe diversity will fit broad queries. So let's say a user is searching for men's shoes, but if it's very broad query, let's say just shoes, in this case, maybe you need to go through refinements, and maybe you can show facets, or you can like provide some navigation based on facets and so on, until you realize, okay, the user is asking to show men's shoes or women's shoes, for example. Then he claims that diversity never works for ambiguous queries. So let's say the query is mixer, it may relate to kitchen item or an audio product. And in this case, like you cannot just diversify in such a way that you pick something from kitchen, something from audio, and something from something else, because you didn't understand what the user is looking for. But in some cases, it may still work, I would argue. So there are multiple cases like this in e-commerce, obviously. And then he also makes a statement that diversity works best for aspects that are not constraints. So if this particular searcher do not kind of care that much about material or maybe style or color, then you can go and diversify in those kind of bigger subspaces of your items in the database. He also pushes to think carefully about the balance between desirability and result diversity. So by desirability, and I really love this term, like he means like, what is it that I want as a user? What is it? Why did I come to this search engine? What am I looking for? And he claims also that users don't care what you have in stock, what you don't. They care for what they are looking for again. And this is grokking that's like the really tough problem. And there is a balance between that, what user is looking for, and also kind of this explorative diversity, because you may just show, specific product of specific color thereafter, but maybe that's not the only thing that you should show. And if you go into implementing this, he suggests to use stratified sampling, not necessarily with uniform distribution. And then the way to kind of compare your distribution with the desired one of the propositions he makes is to use KL divergence as a penalty, for how off you are from the target distribution. And the problem there is that if you start producing these different distributions, you may end up in combinatorial explosion. So you may actually, to solve that, you might choose greedy approach to find just one distribution that kind of works for you. And another blog post that I would like to call out is by you, Christian Bergum from Vespa. So he actually doesn't kind of necessarily go into the weeds of kind of explaining the pros and cons, but he mostly focuses on implementation side of things, and also gives you a method called grouping, which also exists like in Solr and Elasticsearch, for example. And he shows you how to make it perform, because at scale it might still kind of not be performant enough. So you might also kind of not consider putting it in production. And with grouping, so essentially what you do is that you pick, let's say, a specific category by which you can group, and then you can kind of stratify through those groups or use some other method. And here he also cites like more complex rules for group reordering. You may choose to kind of sort your results group by group, or you may choose to pick like the most relevant items from the group and then showing them in some interleaving manner. And he claims again that scaling diversity, and I totally agree, is an important consideration. Over to you, Dano.
So a good intro to look at what we want to achieve with the diversity is an example that Eric Pugh gave in a presentation on the, was it Berlin buzzword or something? Well, anyways, you can go to the next one. Where we have on the left side a query in some web shop, I guess, for bicycles. The query on the left side returns 9 out of 9 bicycles that are somewhat different. They are all bicycles. If you would rate them by relevancy, you would get a perfect score. They all match it pretty much exactly. But then if you look on the right side, we have a more diverse result with bicycles on the top, which still makes sense. But also like bicycle gear and bicycle like locks and fenders and lamps and whatnot that you, as a, I guess, bicycle buyer, are probably going to want to buy as well. And at least in this example, they showed that they get more clicks and in the end more revenue by also showing that the extra gear to the user, not only just showing the bicycles. And of course, this also shows that this particular web shop is selling all the accessories as well, and not only the bikes. So, like the showing some more diverse results. Listen, in this case, is a good thing, while showing only the most relevant ones is less good. And one way of like defining how diverse something is by looking at its entropy. Entropy is a measure of uncertainty and gives kind of more power. If more surprising things come up more often, then you basically have more entropy. And if something is not surprising from a set, then you have less entropy. And that's at least the general intuition behind it. You can go to the next one. And we can, of course, define this as some mathematical formula as well. But at least for this one, the intuition is good enough here. So that basically means that if you want more diversity, then we want to have less certain results or more uncertain results. And that means that we have more entropy. And of course, on the other end, if we have very similar results, then the entropy is going to be low and all the results are going to be same-ish. And when we look at the diversifying the search results overall, we have some sweet spot in between the more precise results and the more diverse ones. Like where on this scale this sweet spot would be is of course something that you need to test and define. Of course, if you have all the diversity, then the search is basically not even happening. Then you just pick something at random, or maybe even pick things that the user wouldn't want to find, just to get more diversity. And to get back to the problem that we encountered when working on these different search verticals, this is an example from the job search that we were looking at. So on the left side, we have a search for teacher jobs. It returns like 3 results. These are the top 3s that we kind of always showed on the first side, since this was a mobile view. And on the left side, we have like 3 results from the same company. 2 of them are in the same location, and all of them are kind of temporary, and I think they have a quite similar salary range and whatnot too. So this is the case that we generally wanted to avoid. And then on the right side, we have the more better results, where we search for manager jobs, and here we get results from different companies, different positions, different regions, and so on. So these are just searches that we did without any diversification and just randomly happened to be good examples for this. And our way of tackling this was so we had the search engine and rather tight performance and scaling constraints. So from the get-go, we set out to build something that first does a normal search pass, finds a small set of relevant items, and then after that we run some kind of diversification on those, which means that the diversification step will only take like a few hundred results at most into consideration. Which then of course made it way faster than looking at the whole set. And in practice, we got the results, and we wanted to find out a way to compare how similar 2 jobs are to each other. I guess that can be measured in tons of different ways too. And then after that, reorder the list so that we get a more diverse set, at least in the top results. So the very first thing we looked at was just fetching a set of results that were already quite relevant, and then adding some naive randomization to the whole set. Of course, this doesn't really do much in the end. It might randomly improve the results, and it might randomly just make it worse.
But works fast.
Yeah, it's fast. It was easy to implement. Worked as a kind of proof of concept of the whole pipeline.
Yeah.
For this. So the next part we looked at was a rule-based approach, where we basically just wrote some hand-tuned rules that how should we order the list of jobs that we got from the search engine. And here you can of course come up with whatever rules that would apply. And then you just order them according to those rules. I think we kind of wanted to have the top three, guarantee that the top three results were always somewhat different, like that they had a different author or different like employer.
Yeah, source.
Yeah, source. That's the term. Yeah, to ensure that like the top 3 page looks more interesting with different logos and whatnot. And of course, you could like work however much on hand tuning these rules to your liking.
Yeah, I guess the next method that we kind of worked on, because in rule-based, obviously, you'll be constrained by the rules that you've written. And if your data changes, then you will have to kind of redo the rules and deploy them again. The rule-based, though, was also quite performant. So it did pass our quality gate on the performance side. But we also wanted to throw in some kind of probabilities into the game. And so we looked at implementing an entropy-based diversity. So essentially, it's like one key takeaway from the formula that Daniel has described. Essentially, it's the higher the entropy is, the higher is the diversity. And we can basically, for every hit for the SERP page, for the hits page for each query, we can compute entropy if we know some probabilities, and so we can compute certain probabilities ahead of time. There are multiple ways to do it. Just naming a couple of here that we tried is you can pick a categorical variable and then basically like aggregate counts and compute the probabilities of each value, or you can normalize the scores of the hits. The second one is probably a little bit harder to do, but still you could, if you know the space of your scores, and let's say you use BM25, you know your document base, you can still do that. So given a set of hits from a query, so you compute the entropy, and so you can produce as many lists as you can possibly in real time, and then you can pick the one which has the highest entropy according to the formula. So basically, just to show that formula is that you add a WI to your PI probability, and you also normalize there. So you use the very similar formula as for the entropy. Essentially, by weighting the document, giving a weight to the document rank, you can force like similar hits not to appear at the top of the result page. We also looked at the next methods where we thought, okay, why not try to throw k-means clustering at this? And how would you go about this? So first of all, k-means clustering is, well, it's one of the simplest clustering methods known, but it's also simple. In our case, means it's sufficiently fast. So it's a machine learning tool for discovering group structure in the data. K-means essentially creates this cluster allocations by computing centroids, so means of data points iteratively. And as long as you have a relatively small amount of points as input, let's say, as Daniel said, 200, you might compute it quite fast. So data points within each cluster are kind of like, well, it says relevant here, so but it means like they are related in some way. And how would you connect that with the diversity? So, and I will show it on the next slide, but essentially you can show data points like within the clusters. Let's say you can, actually, let me move here. So on the left here, as input, we have these document indices. You run a k-means algorithm on them, and you get, let's say for k equals 2, you'll get 2 clusters. Essentially here, you can like, for example, pick you can pick in such a way that you show the first cluster at the top, and then the second cluster below that. Or if you happen to cluster them like this, you could actually pick the rank 1 from cluster on the left, and then rank 5 from the cluster on the right. And then you continue picking like in the order, like 2 from the left and 6 from the right, 3 and 4 from the left. And that's how you did the interleaving. There are obviously other ways and also other factors that you can put into this game. For example, alluding to Daniel Dankelang's suggestion, compute entropy and also pick some signals from the demand itself. So for example, knowing the interest matrix of this user and also some popular items, you could kind of influence this like probabilities and this clustering. But anyway, that was it. And we will show you some of these methods today as well in a demo. And the last but not least, we tried DPP. And I think, Daniel, you want to take this one as well?
Yeah, sure. So DPP is a short for determinantal point process. It's something that's originally based on some phenomenon in physics, like quantum physics or thermal equilibrium. But it's also used can be used in image search and document video summarization and other machine learning related tasks. So the idea is that you have a matrix of that describes the similarity of your things, whatever you have, and then the structure makes it quite easy to compute repulsion and kind of similarities between these things. And the really cool thing with this setup is that like usually finding the maximum path through or way of selecting this selecting points is going to be NP hard, but there's some good greedy algorithms that speed this up to make it quite applicable to this case. And in practice, it turned out to be pretty fast. So we basically implemented this and based it on some research paper that also had some code on GitHub.
So just to add here, we have, it's not a complete visualization, but basically if you have document ranks like this, the way this algorithm would work is that it uses the method of repulsion. So it tries to push items that have some similarity far away. And so if that's expressed as a distance between items, then you could say, okay, I pick the item number 1, and then I say that the next one will be number 2 because it's maximally far away from it. And the third one will probably be this one because there are no other items which are like as far away from the 2 here. And then you'll pick number 4 because that seems to be geographically like the furthest point. And then you'll probably pick like 6 and 5, something like that. So that's how the algorithm kind of works in a nutshell.
And the overall nice thing with like both DPP and k-means is that they are based on some kind of similarity measure. So that makes it quite easy to to apply them to pretty much anything, as long as you can come up with some good similarity measure. Let's say if you do some kind of text search or text processing, then you could use sentence embeddings to compare sentence vectors, to compare your sentences to each other, and then you can compare the distance between those, or like the dot product or something, and compute your similarities. For categorical data, you can of course just encode the categorical data as vectors and do the same comparison. And there's also cases like if you have a recommender system, it will also kind of describe the distance between items in the system. So we kind of built all these methods, plugged it into our search engine, say a post-processing step, and then of course we needed to evaluate whether this actually worked or not. And we generally had quite strict relevancy requirements. So our main goal was that we would get some more diversity without letting the relevancy suffer really at all, like preferably at all, but like of course a small hit would be acceptable. And then also was planning to run the like follow up on click-through rates and other user metrics after deploying the algorithms to see if like that's in the end the ground truth, whether something is better or not, to see if you get more or less interaction or more or less click-through or more or less whatever metric is the underlying business metric for that.
Yep. And I wonder, yeah, I think it's time for the demo. Yay, no more slides. So for our, I hope you guys see Cupid. For our process, we have implemented Cupid as our QA system. So for literally for every change in our algorithm, for every even like feature, we always resorted to Cupid to make sure that the changes make sense and they hold water. So here, actually, I'm gonna start with, we have few movies. Essentially, we took the OSC open source repo with movies meant for indexing in Elasticsearch. There are like a bit more than 8,000 movies. And so on the right here, you can see that the query looks a little different than Elasticsearch query because, well, it does have the query parameter, but it also has the method. So essentially what we did is that we plugged in our API, search API into Cupid. And well, it's possible to do, maybe not many know this, but you can teach your API to speak the lingo that Cupid expects, and that's basically Elasticsearch syntax in this case. It could be Solr as well. All right, cool. So we have a few movies here. If there are any movies from the audience, please shoot them in the chat. We can add them as well. So we can start from the first movie, Mr. Bean. Well, it's not a movie. It's, let's say you have interest in Mr. Bean, watching movies with Mr. Bean. And here, when we sort with the default method, essentially it's behind the scenes, it searches in the title and also in the overview, but there is no boosting involved. And so here you can see there is some movie called Bean. Obviously, genre is comedy. And then Mr. Bean's Holiday, some family comedy movie. And then the rest of the movies, essentially, well, I did go and kind of rate them on the scale of 0 to 3 and using DCG at 10. And here you can see some movies which are less related, like Moneyball. Actually, almost all here are, well, to my extent, not representative of Mr. Bean's talent. And okay, cool. So we got like 11.42 as the score. And yeah, I don't know, is it a diverse set? Is there anything to diversify here? But let's look at k-means approach. So k-means actually did diversify a little bit, because you can see that the first movie, Bean, has disappeared and only the second one remained. And then it suggests you to watch some other like family comedy, Mr. Magoo. I never watched that, maybe it's good. And then another comedy here, and a few comedies more. And then it pushed this Moneyball, which is drama, like down. So it's not maybe what you're looking for. But again, it's not that the algorithm understands that you're looking for the comedy, but it just happens to be. And its score actually went down, as you can see. Well, why? Because the top movie is not there. Okay, let's look at DPP method. So here, first of all, the score is the same as without any diversification. And well, it actually didn't do much otherwise. So it didn't, well, it did shuffle some movies here. So it wants me to watch documentaries and crime and thriller, but it also keeps Moneyball as number 3. So I'm not super happy about that, but yeah, that's what DPP did. But in any case, what you can notice is that it's kind of like pushing items a little bit like away. So for example, we use genre as the categorical value, and so here, like comedy is top one, then this one is kind of combined family and comedy, but then there is drama, crime, thriller, documentary, horror, adventure, science fiction, and so on. So as you can see, it tries to basically use this repulsion method. So it pushes these similar items away from each other, and then it kind of pushes similar items to the ones at the top down. So for example, drama got pushed down. Daniel, do you want to take some query here? Explain.
Yeah, I guess we could go with, let's look at the Hunger Games. I think that one had.
All right, let's do Hunger Games.
Had kind of result that also made sense. This is the one without diversification, right? Yeah.
Mm-hmm. Yep. So at least one movie, Hunger Games.
So we get the first one at the very top, and we also get the I think that's the second one or something. Quite high, and there are a few more as well that are kind of way down.
I think Charlie suggested Tremors. Is that the movie, or is that an exclamation?
I think it's a movie, but
let's try anyway. So okay, so then with k-means we have Hunger Games as well.
Yeah, and in this case, I think it just because k-means doesn't take the scoring into account at all. We just look at the similarities. So here the good result got probably pushed down because we decided to select the action cluster first.
Yeah, but like no Hunger Games here, right? At least
no, it's like way down.
It's almost like if you're tired of watching Hunger Games, then you could say, okay, what else can I watch? K-means, and then it will tell you that you should also watch like the movie called Hunger, maybe. And with DPP, let's see what happened here. Yeah.
Yeah, here we kept the first one at the top. Then we have some random comedy and action and horror movies in between. I guess in this case it pushed the second one farther away. This is, I guess, a case where you would look at the scoring and see that, or tune the scoring so that that would have a higher weight in the whole system to actually not push them too far away.
Yeah, and it also focused on game. Well, that's because the underlying retriever, the way it works is that it also like allows one word to be found. And so, yeah, the game is another movie to watch, obviously. Okay, and I think we had another case. Let's see, was it? Let's try the Martian. So the Martian here is that, well, first of all, the original retriever didn't like make a good job here because the Martian is not at the top, but it's top 3 at least. And its score is like 10, 11. Let's see what k-means did. So actually the same score. And I think it didn't much do anything here, except that maybe it shuffled some movies here. DPP went up. So look, the original score on non was 1011, and with DPP we get 1105. And that's because the Martian movie crawled one level up. It's not at the top, but maybe you watched it already, so why watch again? Although I personally love that movie. So yeah, you can watch something else, like Frankenstein meets the space monster. I don't know if that's related to Mars, but Mars needs moms. That's obviously about Mars and Martians. So yeah, you can watch that. And as you can see, it continues to do the same thing. So it pushes similar items apart. So it's like action, drama, horror, adventure, comedy, and so on. Let's see actually what happened to Charlie's movie, Tremors. Okay, Charlie, you have to say, is this the movie or not? Probably it is. Let's assume. You think this is the movie? Yeah, and everything else, I don't know. Is it a sequel? It sounds like it's a sequel, so maybe we can say this is a perfect one, but I apologize because I didn't see this movie. But there are only 4 results, by the way, here, so it's not like there is much to show or diversify. Anyway, so that's none. So let's go and reload this page. And oh, what happened here? Is it stuck? Is our backend up?
I don't know. Did it die mid presentation? Oh, no, it works for me.
Oh, it works for you. Okay, so let's see. Is this HTTPS problem?
No, you're on HTTP, so I don't think it matters.
Yeah, there is something going on. So maybe k-means failed. We don't know. Okay, how about DPP? Oh, DPP worked. So there is a bug in k-means. Okay, that's a demo effect to know about. So DPP actually improved with diversity. Yeah, nice. So Tremors is still at the top, and then you can also watch Tremors 4, but after that you can't. You should watch Sand Serpents and then Tremors 2. But that's only 4 movies, so not much to diversify on. And maybe you should also apply some judgment when you do this. Maybe, you know, if you have less than a certain amount of items, just don't diversify, apply your ranker. Yeah, I think we are mostly done with the demo. I guess, are there any questions? Yeah, Charlie can break anyone's search engine. True, you've proven it. Thanks for doing it. You found a bug, we'll fix it.
Fantastic. Thank you both. And I apologize for my breaking your search engine. It wasn't deliberate. But it's just a talent I have after many years working in search. So this is your chance for questions for Daniel and Dmitry. Please drop them into the chat. We have quite a small group, so I might even let you ask it on your own. But please do. Let's have some questions. Come on, somebody must have a question.
At least we have people.
At least you have people, yes. So Ansgar is asking, he hasn't fully understood the entropy approach. Is there a text where you can read more details?
Yeah, sure. I guess maybe we can try to share the code as well, so you can kind of read it. But I mean, in a nutshell, the idea is that, first of all, you have the entropy formula here. So Eric Pugh had a claim there in the Berlin buzzwords that essentially entropy is a measure of diversity. So the higher the entropy is, the higher is the diversity. So it's like uncertainty of your results, right? And so it also means that, for example, you can introduce some important event in the system. So by importance, I mean that you can say, okay, a specific website from where jobs come, that should be super important. So it will keep disrupting your search engine result page, right? Because its probability will be higher. And so this is a formula here. And what we did is we basically add weights to it. So we can say, okay, for a specific probability, we can also like add a weight of its importance. So the probability is computed from the output of the search engine. And then despite that, you can still say, okay, I either like penalize that, or maybe I even amplify that probability further, depending on what you feel like is right. And yeah, and there are like just different ways you can compute probabilities. And then also, I just didn't say much about weights, so maybe that confused you. I think what we can do is we can just share some code so you can try to go through it. But in reality, this method is probably rather fast, but it's not super meaningful, or at least we couldn't find a way to make it more meaningful for us. But I think it all boils down to how you define weights as well as how you compute probabilities. So what do you include? Sorry that I cannot answer in more detailed fashion right now, but I think sharing the code might help you.
Fantastic, thanks. Thanks. That's at least some homework for you there, Ansgar. Eduardo asks, do you have any evidence if diversity is more useful in some search scenarios than others? For example, product search versus enterprise search.
Yeah, I mean, it's hard to answer because we've been looking at diversity now only as part of one vertical search engine, so that's the job search. But we already see that applying a similar method or set of methods to other search engines like real estate could also bring benefit. The typical problem that you first need to ask yourself a question like, okay, what am I unhappy with? And what we have inside our search engine teams is that we have a quality assurance department, and they regularly score the search results based on a number of parameters like recall, precision, and also diversity is one of them. So diversity is kind of like subjective, right? So what is diversity? What is a good diversity? What is not? Do you need it? But obviously, when we showed you the example with teachers, like the teacher query, it was kind of like obvious that you don't want to show this to the users, right? Because this tells the users that, gives a wrong impression that you only have jobs from ABC teachers. Maybe you don't in reality, right? The same goes to real estate. The same goes to product search. I'm not sure what you mean exactly by enterprise document search, but there you can also have some parameters that will point, let's say you are showing documents of certain type and you dominate the screen. And if it's more like explorative search, then users will be kind of puzzled. Okay, do you have anything else? What do I need to do to see that something else? And so with diversity, you kind of breed them and you show them, yes, you do. Yeah.
I've certainly seen a need for diversity in product search and e-commerce search. I think to add here, because it's whether in your use case you want to show only products from one brand. Now, in some cases you do, depending on your agreement with that brand. but users probably want to see products from a diversity of brands. I think it would probably be driven by the use case and that usual combination of what's good for the business, but what also is good for the user. Carlos asks, what's the best way to validate your diversity? Offline validation or A/B tests?
Daniel, do you want to take this one?
Yeah, I think both approaches are useful. Of course, you can't A/B test before you actually run it in production. So some kind of offline validation is, of course, good to make sure that your results don't become completely horrible, or that your thing doesn't work. But in the end, I do think that A/B tests are the best way to actually get the truth of whether it works or not, because it's in the end a subjective thing. So you can of course say that, oh, this is really good. Our results look really good when they're so diverse, or maybe they're less diverse, or whatever the measure is. But like in the end, I think it's the users who decide if it's good or not.
Thanks, Al. Could you use, Nico asks, could you use locality sensitive hashing to come up with K buckets where you try to assign docs from a set so you return only top diverse docs from each bucket ordered by the top doc scores? You may have to read that from the chat, so I'm not entirely sure it came across and how I told it.
Yeah. Hi, Nico. Yes, I think you can. And I mean, in a way, what we did with k-means, it's also like in a way grouping your results in some fashion. And so, yes, LSH can be used. And you can then use like some distance metric to kind of sort them somehow. One thing that's important for us is like how fast this works, because we have like thousands of queries per second as the quality gate. And so if LSH is capable to build like the buckets within that range, because in that like query, we also retrieve results from the search engine, we also enrich it, and we also run the diversity. So diversity has just a few milliseconds there. So if you can do it, yes, obviously you can do it. And we didn't demo it, but in the same qubit setting, we have set up vector search. So we retrieve vectors and then we also group them and run k-means. But your question is more about kind of using LSH for bucketing for diversity. Yes, I think it could be used for sure. That could be the sixth method.
Fantastic. Sujit Pal has a question. Hi, Sujit. I would still be interested in the other results for the teacher query. And if I was looking for a job, would grouping be a more effective approach?
So if I understand the question correctly, Sujit, you mean like you would want to group the results so that you get rid of this kind of duplicates, right? So, and then you just show kind of group by group, right?
Exactly. Simple Solr grouping is what I was looking at.
Yeah, makes sense. Yeah, for sure, you can do that. One problem that for us that was not performant enough. So at web scale, if you run like aggregations, they are quite slow, unfortunately. And so we had to rethink the approach. So we had to have some greedy algorithm that could achieve similar, but without grouping on the search engine side. But yeah, I mean, if you don't have that constraint on QPS, I think you can also apply grouping as actually Yu Bergum has alluded to in his blog post, and which I described also during this presentation. Yeah, and make it effective if you embed the grouping algorithm inside the searcher on a node, then that would be even faster. So you don't have to go through the network multiple times. I hope that answers your question.
Yes, it does. Yes.
All right.
Fantastic. Well, we've come to the end of our questions. If you've got a last question for Dmitry or Daniel, please think and type it now, please. Wonderful. Okay. Oh, there's one. Here we go. Ansgar's back with, is there a clear winner among the algorithms you've tried?
Daniel, you ran the benchmarks, so you want to take this one?
Yeah, I think performance-wise, the DPP performed almost as good as the like really naive ones. So, and also result-wise, it did, I think, the best, at least in our case. So I think that's at least a good candidate to start with.
Great. Well, I think given we have no more questions, I wish we can leave it there. So I'd like to thank Daniel and Dmitry for speaking. Do check out Dmitry's fantastic Vector podcast, and also join. Do follow them both on Twitter, and you're both in Relevant Slack, I believe. So any more complicated questions, you can jump in there. If you're not a member of Relevant Slack, then how on earth did you find out about the Haystack live meetup? So just let me share my own screen. Let's come back to my cards here. So thank you again, Dmitry and Daniel. That was fantastic. And thank you for stepping up. To keep Haystack Live going, we need your talks. So over the break, over the holiday season, while you're relaxing quietly at home, or eating far too much, or whatever you're going to do, please have a think about what wonderful talks you'd either be able to give or you'd like to hear at a Haystack Live event. We run these meetups about once a month or so, but we do need more talks. So please go out and try and find some for us. And you can submit them via the form on the Haystack website, haystackconf.com, or contact us directly through Slack or something like that. We'd love to have more talks for 2022. Do have a lovely holiday season. Do relax, do enjoy things, and maybe step away from a screen for a little while. I know it's difficult these days not to be looking at a screen for something, even for Christmas parties. And we're looking forward to a great 2022. We're hoping to bring back Haystack, the real life conference in the US in April or so, and in the EU in autumn. But again, that's all subject to whatever madness we're presented with next year. But we'll certainly carry on running Haystack Live. If you're interested in our training, the details of training are on the website, of course. Elasticsearch and Solar courses coming up in February, and Linear Rank in March. Do book soon to avoid disappointment. And that's it. It's been a great year for search and relevance. I see so many more innovations happening, especially in the exciting vector search space. And I think we're going to see even more exciting stuff coming next year. So thank you all for coming to Haystack Live. I'm Charlie Hull from Open Source Connections, and we'll see you all back here soon.
Thanks, guys. Thanks, Charlie.
Thanks.